Hi everyone, I'm Anish, the founder of DevVoid. Today we'll be looking into the 11th episode of DSA AI. In the previous episodes, we looked into reverse linked list and solved various aspects of it and looked into it, right? To quickly reiterate on what we learned in that, right? Or rather, not what we learned, rather the topics that we focused on was, of course, linked list, right? What is a linked list? It's basically a collection of nodes where each node points to the next node and all the nodes have its own value. Okay, that's a quick reminder of what a linked list is, because today we'll be looking at the next problem in linked list, that is merge two sorted lists. I have it open right here. This is going to be the problem. But right before this, I really do want to make sure that you guys understand the concepts that we're going to use in this problem. So quickly, just to make sure you guys remember linked list as well as sorting, which we have already covered, I want to just show you here. Let's just reset the canvas right here. And here you go. Right. So linked list and sorting. Before even diving into the problem, I want you guys to remember these two topics. Linked list is a collection of nodes where each node points to the next node. And this will have some value, 1, 2, 3, and so on. And when you say points to, what does that mean? From a coding standpoint, it is actually address. Okay. Basically, think of it like I'm in house 1, then so the mail guy comes to my house, and then from my house, I tell him, hey, go to the next house, which is in this address. So he'll come here, he'll go there, and so on, right? Basically, each node has a value and an address to the next node. That is what a linked list every item comprises of. We have several such items which forms a list or a collection or a group, right? So that's what's happening here in linked list. Every node, linked list first of all is a group of nodes in which every node has a value and an address. Okay, where address is to the address of the next node, so that we understand we get a link and a list. That's it. Okay. That's a quick revision though. On more detailed explanation as well, you guys need to go to the previous video, firstly. Secondly, look into the AI aspects and, try to, I also, by the way, before we proceed further, I also have prepared some interesting things on the AI side to help you guys in your learning journey, because as I told previously, this whole series is about DSA AI, where I'll keep adding like small AI helpers to you guys so that we can all focus on the learning aspect and learn together, right? I really don't want to hinder or stop your learning process to only the things that I've done in the video. You guys do need to explore by yourself as well. That's the only way you're going to learn truly. So I have prepared something for you guys today so that I can help you out in that journey as well in a better manner. But first, let's look at today's problem and then I'll add that part later on. Okay. But yeah, this is linked list. Next part is sorting, of course. Sorting means what? Sorting means, arranging a set of items in some order, either ascending or descending. What is ascending? It is from smallest, let's say 0 to 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 9, 10, and so on, right? Descending means 10 to 0, right? 10, 9, 8, 7, whatever, right? It doesn't have to be like 10, 9, it can be 10, 8 also, that's different matter. But the point is lowest to highest and highest to lowest. Those are two orders we can think of, ascending and descending order, and that's sorting covered for as well, just as a quick refresher. Now, why is this too important? Because of today's problem, of course. Today's problem says that we need to merge two sorted lists. A list actually is an array, but if you read the problem here, you'll see that you are given the heads of two sorted linked lists. Two sorted linked lists. Now, what does that mean? We can look at the diagram here for easy understanding. It's sorted in which order? Sorted ascending order, because lowest to highest. So 1, 2, 4 and 1, 3, 4. Given these two, you guys need to combine these two to make something like this: 1, 1, 2, 3, 4, 4. Got it? That is the requirement. That is the output given these inputs. Now, to quickly also add one more aspect, we are going to solve this in two ways. Okay, I have a list of solutions, more than two actually. I have almost like 5 different solutions, to be honest. But for the scope of this, as well as complexity is concerned, we have 2 main solutions you can think of, and I will go to that. But before that, let's see the inputs, outputs, and quickly just see what's happening. Right? We have 1, 2, 4 right here, and 1, 2, 3. Okay. Combining these two, what do we get? We get, I'm just gonna write down here. Okay, I'm gonna write down here 1, 1, 2, 2, 3, 4, like this. Okay. Understand what did I do? I combined the 2 inputs that they give, which are also sorted, and I created an output, which is also sorted. That's it, right? So in simple words, what are the solutions you can think of? What is the process you can think of that will allow us to take these 2 inputs and give us this one output, right? What is something that you can think of, right? Sorting by itself probably might work, who knows, right? Because let's think of it in this manner. Okay, sorting arrays we know how to do, right? Sorting arrays, I hope you guys remember how to do. If not, I believe we have done before in one of the previous sums, so take a look at that. But sorting arrays we know how to do. We have a dot sort function in Python as well that you can directly utilize, right? So the question here is, can we use this to do some magic, right? So what will we do here? We will see for sorting arrays. Take the linked list. I did 1, 2, 3 and 1, 2, 4. Put that as an array now, right? Just add them directly. 1, 2, 3, 1, 2, 4. That's it. Okay. I made one array that has all the values, and let's sort it. What happens that time? We get 1, 1, 2, 2, 3, 4, right? As an array. We want a linked list though, and then we'll convert it back to a linked list. Done, right? That's it, right? Isn't that a very interesting way of solving it? We used something that we already knew previously, which is sorting an array, and applied it to linked list by doing what? By doing a conversion process. This is one of the ways of solving a lot of problems actually, where you convert the current column into a problem that you already know the solution of, and then use that solution and convert it back, right? So that's a very important aspect that you guys will learn as well over here. Although I do want to mention that this is not the best solution for this. It's one of the solutions, right? So what do we do in this whole thing? We take the 2 linked lists at the top right here. Take the 2 linked lists. I'm going to make sure you guys understand that's a linked list as well by drawing it in a symbolic representation like this. I take the 2 linked lists, make one array out of it, sort that array, then I make the linked list again from that. Okay, so that's the plan here, and let's quickly look at how to implement this plan. Okay, I do have the code already ready here because it's going to be a little tedious if I start writing code for all of these things from now on. And I'm just going to copy the code from here. We should write here, right? So we're just going to see what's happening here. Okay, in line number 8, we have values which is the array that used to represent all of the items. So basically this one, okay? Now what we'll do is we will, use the list one items and add all of the items to the array. List one. Then what we'll do is list two items. We will add to the array. That will give us this much. First we add list one, then we add list two. Done, right? So till here, that's what we did. After that, we sort it, which will give us this. Okay? That's what we'll do in line number 20. After that, we check one thing. If by any chance there was no values in this, then we stop it there. Of course, we can do this prior to this itself, but we did it here in this one. Okay? After that, we create a head node, because in linked list, we always give the head or the first node. List one, by the way, over here is actually a pointer to the first node. That's it. List two is actually a pointer to the first node over here, this one. Okay? Similarly, head is a pointer to the first node in the output right now. Got it? So we'll say head and put the first value in the array in that. And then what we'll do is we'll have another variable which we'll use for a certain purpose, we'll see later on, called current, which points to the head itself. Okay? Head, you forget now. Head is just the first item and that's it. Current is what we'll use to add more items now. Okay? We'll say current.next, which means head in the beginning, ka next item is equal to the next item. Got it? Values of 1. And then we'll go again next. Then values of 2, add that. Then go next. Then values of 3, make it a list and add it. Then go next. And so on. We are literally just repeating that cycle of making a new node, going next. Making a new node, going next. Until we reach the end of the array. At that point, head has already linked with everything using the ability of what we did in the previous one, in the for loop. And at this point, we'll have the result. But what are we doing in between the sorting and here to diagrammatically represent? I will just showcase so that you guys have a better understanding. 1, 1, 2, 2, 3, 4. Right. So here, if I showcase, it will become 1 goes to 1. No, our first iteration, it does this. Head is this one, with the empty pointer. Current also is this one. After that, what happens is, head is still one, first one only, but current becomes this one that we just added. It's not 2, by the way, it's 1, okay, my bad. But the second item is 1. After that, in the next iteration, it will become 1, 2, and 1, 1, and 2. Where this 2 is this third item. And current is also the third item. Head is always remains as the first item. Don't forget that. Okay, that's what we need to return the result as. So don't forget that. And we'll keep repeating like this. We'll go current 1 by 1 by 1 by 1. Keep adding new item, go next. Keep adding new item, go next. Basically, current represents the last item, always. Head represents the first item. That's it. And that's what using that loop, we keep adding more items at the end of this linked list. And then we say, hey, this is the beginning of the linked list. The rest you can look into it. Take care. That's it. Right. And that is pretty much what's happening in this loop over here, in this solution. Just one second, give me 1 sec. I'm a little bit sick, so I just want to make sure everything's fine. 1 second. Okay, perfect. So, yeah, to go back, we have current and head, and we are pretty much done with this logic. So what we do? Quick revision. Values, add list 1 to the values, add list 2 to the values, sort that array, very important, not a list at that point. And after that, initialize head with the first item. Okay. Finally, keep adding all the items in the array to the list, one by one. And then when you return the first element, you get the linked list in this format. That's it. And that is our solution. If I submit this right now, we will get it right. I already have submitted once to showcase it. But yeah. And this is what's happening, right? So this is a fine solution. I won't lie. I mean, again, don't use too much of what's happening here as a good representation of what's complexity and whatnot. Because we will think about the complexity right now. Before that, I have to just add a couple of points. I'm just looking at my notes once. Yeah, okay, that should be good. So, complexity-wise, right? Let's analyze now. We are making an array, right? We are making an array. Let's say we have list 1 that has size m and list 2 of size n. Our array comprises of m plus n items. So a space will be m plus n. Now what's the time take? Right. This will take O of m. This will be O of n. This will be O of what? The fastest, sorting algorithms are n log n. And that will be our bottleneck here actually. So our time will be based on the sorting time taken, and sorting an array of m plus n size is O of m plus n into log m plus n. So this will be the space complexity, that is m plus n, and this will be the time complexity. Okay, hi everyone, I lost my recording over there. I'm not sure what happened. I just cut over there. So just to quickly reiterate on what we were discussing, we have a space complexity of O of m plus n and a time complexity of m plus n into log m plus n. Why? Because the fastest sorting will take n log n time. So in our case, we are sorting an array of size m plus n. So it takes a total size of m plus n into log of m plus n. Okay, that's the total time taken. Similarly, space is O of m plus n. Okay, and that's the overall, how to say, space and time complexity breakdown for our first approach, which is brute force. Now we will do something more interesting. Okay, we will not do using brute force. We will do something where we do something. I won't give a word for it because maybe you might get clues and whatnot, right? So this is what we'll do. Okay. Like, look at this linked list now. At any point, our list 1 points towards the first item and list 2 points towards the second first item in the second linked list. See, because they are sorted, that's very important. That's because they told they're sorted, right? We can use a special thing because of that. Okay. What we can do is we can say, hey, I only need to compare the first items. Okay. And see which is greater there. If they are equal, I'll take the first item itself. So in these two, they're equal, so I'll take one only. And then I will compare these two items because I'm done with this one, right? 1, 2. I'll compare these two and see which is smaller because we want the smaller items, right? My bad, I said greater, I think, in the previous one, but we want smaller items. So 1 is a smaller item and we'll take the 1 over here. Add there. Remove this and compare the next top, friendmost items. Will be 2 and 2. Again, take 2 and done. First one, because that's what we decided, right? Then compare 2 and 3 and see, oh, well, this looks like the smallest item, 2. So I'll take that and done. I'll add that here. Finally, 3 and 4. I'll take 3. I'm done with that. Then I'll take 4. I'm done with that. So I get the actual linked list that I wanted. But this time, we never did some sorting. We never used a special array. We checked each item's topmost item every time, right? not topmost, I guess the lowest values every time, which is the head, right? We check the head of every item, every linked list, one step by step, compared it and used it. That's it, right? So what do? We compare the heads. Yeah, I'm not really sure what's happening. I'm having a lot of issues with the system today. But yeah, so basically, we compare each nodes and see which is lower, and the lower ones we add to the items and then done, right? And that's it, pretty much, right? Keep adding items one by one, and then do it one step by step. That's pretty much all we need, and that's the whole logic we are looking into right now. So on this merge to sorted list, right? Compare heads, lower one will be added to the new list or the result, and keep repeating. I'll go to the code breakdown because it's more easier that way, I guess, for any other part. So I'm just going to copy what I have here, paste it right here, and boom. So what do we do in the beginning? We see whether our list 1 is empty. If it is, return list 2, right? Similarly, we check whether list 2 is empty. If not, if it is empty, return the list 1. Okay. Finally, after that, edge case conditions are checked, where one of the lists are not present. What we'll do is we'll check the values as I mentioned just now. List 1's value, which is the top head of list 1, and list 2.val, which is the top head of the list 2. Whichever is, less than or, smaller value, that will be used as the head over there for our result. Okay. So our first element or the first head of our result will be the smaller value. That's what we did as well in our example, right? That's what we did in the beginning one. This will be our head. Okay. After that, what do? We see the current logic, same as the array one. Okay. Where we make a current item which acts as the end pointer or the last element's representation. Current is the last element. Okay. Head will be the first element. Current will be the current element, to be honest, not the last element. In every iteration, it will be the last element. Think of it like that, right? Because we need to add to the end every time, right? We need to add to the end every time. You see, this 2 was added to this 2's end of this list. This 3 is added to the end of the list every time you add, right? That's the whole purpose of current, to allow you to understand where you should add the item. Okay. So if you see here, if list1.val is, then we do the same comparison every time. Every step is literally the same thing. Compare the values, which is smaller, add that, and go to the next step. And keep repeating till what? While list 1 and list 2. What does that mean? That is, list 1 is not empty and list 2 is not empty. Okay. So as long as both the nodes are not empty, we can compare them, right? If they're empty, then we are done. We don't have to compare anymore. So the condition is that while list 1 and list 2, which means as long as list 1 is not empty and list 2 is not empty, that's it. Okay. And as long as that is the case, keep checking. If one of them becomes empty, we will add the non-empty one to the end. So for example, what we're doing is, if I have 1, 2, 3, and I have 1, 2, 4, 6, 7. Okay. What will we do? We'll compare the first 2 and we'll add 1 from the top one. Then we'll compare 2, 1 and we'll add 1 from the bottom one. Then 2 from the top one. Then 2 from the bottom one. Then 3 from the top one. Then we are done. This list is empty at this point. So add the remaining part directly at the end. So it will become 4, 6, 7 instantly in the next iteration. Got it? The remaining part will just be added at the end of our, iterated list or whatever, right? So that's what's happening in this line, in line number 31. Whatever is remaining in whichever list is remaining, add that to the end. That's it. And then we return the head. Okay. So that's like the quick logic that's been happening for the both of things. First one is like the iterative array approach, you can call it as. And the second one is like a in-place two-pointer approach. It's two-pointer because list 1 and list 2 is like two different pointers, right? But yeah, this is a better solution. Why? Let's analyze. Okay. First of all, already you can see we are not using any array, no extra space. So space complexity is O of 1. No sorting, only iterations. Iterations at the max could probably be the whole, list 1 plus list 2. So O of m plus n is the time complexity. Space is O of 1. Compared to the previous one, which was m plus n into log m plus n for time, and space was m plus n. So you can already see this is way better solution. O of 1 space is like insanely good, and O of m plus n time is also pretty good, right? Compared to m plus n into log m plus n, yeah, very good. Summary of what's happening here, and that's pretty much it for the solution side. Like I said, I will explain some interesting aspect regarding AI. I told you this one, so stay tuned for that. Right now, I'm going to go to Claude because ChatGPT has been giving me some problems with the running. I'm not sure what's happening for me, but this will not affect your side. You guys can use ChatGPT, the free ones yourself to do this. I have a special prompt ready here. It says you are a DSA learning mentor. Your role is to guide me through learning concepts and solving problems without providing direct solutions. I've written a lot of things over here of how it should guide me and whatnot. I do want you guys to take this one, use it. I will be attaching this in the either comment section, I believe, or the description, one of them, and you guys can use it. So I'll put this right here, and it's ready now. Then what? How do you use it, right? I'm going to copy this problem and just paste it here. This is the problem I'm solving. Help me out. Okay. Yes, so you see, it says great problem to work on. Before you dive into the approaches, let me make sure you have a clear picture of what you're dealing with. Can you walk me through what this problem is asking you to do in your own words? So this starts validating your understanding and keeps asking you questions to make sure you understand and keep repeating it. Okay. Okay. This problem is asking me to, so basically what you should do is you should put your thoughts and talk to it and literally speak your thoughts to it. This will also help you guys to prepare for interviews, by the way, because that's what you should do in interviews as well. Speak your thoughts out loud. Okay. So the problem is asking me to merge two sorted linked lists and make a new sorted linked list. Linked list consisting of all the elements. Right. So that's what the problem is asking us to do. Now it says, I'm curious about your approach. When you say new, are you thinking about creating brand new nodes or rearranging? See, it's giving you hints, right? It's giving you hints, but it's not giving you the solution. It's not giving you the code. That's very important. So the way this works is it gives you hints, okay? But does not give you the exact solutions. That's what you should think of and whatnot. That's the whole point of this prompt. So see, creating brand new nodes or rearranging existing nodes or, yeah. So but here's a key question to help you think through. Imagine you're holding the heads of both linear nodes. How would you decide which node should come first in your merge? So it's asking you questions to think about the good answers, the good results, right? So, okay, if I have both the linked lists in my hands and I have access to the top, then I would perhaps compare them and use that to mind, right? That's all. Comparison approach is spot on. Let's dig a bit deeper into the comparison idea. When you say compare them, what specifically are you comparing? And what do you do based on that comparison? Try this. Let's say you're looking at the first node of list 1 and the first node of list 2. Which one goes first in result? After you pick one, what's your next step? Right? So basically, it literally, drives you down to understand every step of this. That's what this prompt does. So I really do hope that you guys can utilize this and help it in your learning journey over here simultaneously along with my videos, so that you can also learn things in your own time, right? That's very important. Got it? But yeah, overall, this is it. I will be sharing this prompt in the uh, YouTube description, I believe. It's called a description or comment section, one of them. But yeah, I was a little bit sick today as well, so maybe this is a little bit off or something. Do pardon me on that. And other than that, stay tuned for the next episode of DSA AI. And this is Anish, founder of DevVoid, heading out. Thanks, everyone.